Alright, notes 5.7 using proofs using coordinate geometry. In this section, we'll be using the formulas that we know from geometry, but we will have some unknowns in the problem. Therefore, our answers will be in the form of expressions. Quick review. Midpoint formula. What we need to know about the midpoint, so our midpoint equals our x1 plus x2 divided by 2, so it's the two x values, and then y1 plus y2 divided by 2. So that will give us the midpoint. So we take the two x values, add them together, divide by 2, the two y values, divide by 2. The distance formula, so our distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And the slope formula, our slope, we use slope as letter m. Slope is y2 minus y1 over x2 minus x1. This is rise over run. So to look at a couple examples, find the midpoint. Well, here we add our x values, so here's x, so we do 2p plus 0 divided by 2, and then our y's is 2q plus 0 divided by 2. So this will give us our midpoint. So what we get here is we just are left with p, and we're left with q. So the midpoint equals PQ. Now for this one, we take our x's, so we have 2p plus 2r divided by 2, and then our y's, which is 2q plus 2s divided by 2. Now these all have a factor of 2, so we can say it's p plus r divided by 2, and then it's going to be q plus s divided by 2. The 2's cancel out, so our midpoint is p plus r, q plus s. That is the midpoint. The distance formula. So when we look at our distance formula, we know that distance equals the square root. So distance equals the square root of x2, so p minus x1, which is 0, squared, plus y2, which is q, minus 0 squared. Well, this is just going to give me d equals the square root of p squared plus q squared. So that is our distance. So whatever p is and whatever q is. For number 2, distance equals the square root of x2, which is r, minus x1, which is p squared, plus our y2 s minus q squared. And we're just going to leave it like that. We really can't. We could do a few things to it, but we'll leave it as the distance of is right there. So that's the distance formula. And then moving on to the slope formula, just going back to algebra, and what we did in, I think it was unit 3. Some examples of slope. Find the slopes. Our slope is y2 q minus 0 over p minus 0, which just gives us a slope of q over p. The slope of number 2, our slope equals y2, which is s, minus q over x to r minus p. So now we can determine the coordinates of an unknown vertex or vertices of our figures. And if we don't know something, we can use a variable to represent the coordinate that's not completely determined by the given variable. Well, if we look at this first one, we know that if a is 0, 0, and b is 0, p, well then what's c going to be? Well, we know that it went up p units, it's a rectangle, so it has to be something p, and d is q, so it went up p and it went over q. So that means c is going to be q, comma, p. It should be a little q, comma, p, but it's not. So since it went up q and right p, we know that c, since it's a rectangle, will give us that value q. Q, and P. With our isosceles triangle, well, we know that D is 0, 0, and we know that E is P, Q. Well, the first thing that we know in F is that the Y value, is 0. Now we can figure out the X value. Well, what we know, since it's an isosceles triangle, this went over P units. So it went over P units. Well, it's going to go over P units again. So since it went over P units and then went over P units again, this is value of F is going to give us 2P. So the value of F, it's 2P, comma 0. Now we get into a parallelogram. So if we look at this parallelogram, we have G is 0, 0. H is P, Q. We don't know I, but we know J is R, 0. Well, one thing that we know about I is that it has the same Y value as H. So it has the same Y value as H, so H's Y value is Q. So it has to be Q. And now what we can figure out is, well, how far did it go over? Well, how is it going over? So what we can do to this is that, well, we know from here to here, this went over P units. And we know that this length is the same as this length. And from G to J, we know it's R. So if this length is R, that means this length is R. So it went over P plus R. So it went over P plus R. And then we know that the Y value is Q. So I is going to be P plus R and Q. And with our square, this is 0, 0. We know that N is P, 0. So we know that this value is P units long. So from K to N it's P. From K to L it's also going to be P units. So the X value is 0. The Y value changes to P. And from L to M, well, this is going to be P. So it goes up P units. And it goes right P units. So it's going to be P and P. With the trapezoid, we know that we have 0, 0. And we know that we have Q is P, Q. So when we look at the trapezoid, what we can say, we need to find R and we need to find S. Well, what we know about R is that R has the same Y value as Q, and Q's Y value is Q, so R is something comma Q. And what we know about S is it has the same Y value as P, so it's going to be something comma 0. We just have to find out what those somethings are. But the thing about a trapezoid is we don't know anything specific about this. So what we can say is we don't know this value, so we can call it A. So R is going to be AQ. And we don't know this value, how long this is. So we can say that this is B. So we can say that this is B, 0. And then we get to our rhombus. Well, we know that this is 0, 0. And we know that U is P, comma Q. So what we know about V is it's going to give us, it has the same Y value as U. They're the same height. So we know that the Y value is going to be Q. But we don't know what the X value, and we know that W's Y value is going to be 0 because it has the same Y value as T. So now we can figure these out. Well, what we know here is that this distance from here to here is the same as this distance from here to here. So if we find a distance from T to U, so the distance from T to U, we have P plus 0 squared plus, or p minus 0 squared plus q minus 0 squared. So the distance equals p squared plus q squared. So we know that the distance from here to here, from t to u, is p squared plus q squared. So from u to v, it is also p squared. So this distance is p squared plus q squared, and then we also have this little distance in here of p. So our distance from here all the way over to v, it's going to be p, that's from here to here, plus our distance of p, the square root of p squared plus q squared. So we have p plus p squared plus q squared, comma, q. And then for w, well, with w, since it starts at 0 and just goes to w, it's only going to be that distance of p, the square root of p squared plus q squared, comma, 0. And if we look at the last part, proving the trapezoid midsegment, well, if it says trapezoid ABCD has vertices at 0, 0, 2P, 2Q, and C is 2R, so we know it's 0, 0. B is 2P and 2Q, C is 2R, and D it's 2S. Well, what we know about C has the same Y value as B, so it has to be 2Q. And D has the same Y value of A, which is 0. So this is going to be 2Q. This is going to be 0. Then it says find the coordinates of M, the midpoint of AB. Well, midpoint, so we use our formula, which is x1 plus x2, so of AB. So from A to B, we have 2P plus 0. So 2P plus 0. And then the Y values is 2Q plus 0 divided by 2. So we know that the midpoint is going to be P, comma, Q. So that's the midpoint of AB. And so this is M. And then this is going to be N. So it's the same thing. Our midpoint is, for N, it's going to be 2R plus 2S, comma, 2Q plus 0, which will give us a midpoint of, these have that common factor of 2, so you're going to be left with R plus S, and this is just going to be Q, so R plus S, comma, Q. So that's the value of N. And then it says find the lengths of AD, BC, and MN. How does the length of MN compare to AD and BC? Well, if we look at AD, the length of A to D, it goes from 0 to 2S, so that's 0 to 2S, so the length of AD is 2S. The length of BC, goes from 2P to 2R. So if the length is going to be 2R minus 2P, because that's how you find the length, it goes from here to here. And then the length of MN, the length of M to N, from here to here, well, this value minus this value. So from M to N, we have R plus S minus P. So it goes from this value to this value. So this is R plus S. This is P. This is R plus S. So from here to here, it's R plus S minus P. And then we can, how does this compare? How does length of MN compare to AD and BC? So if you look at AD and BC, so AD is 2S plus 2R minus 2P. If you find the midpoint of this, alright, if you divide that by 2, if you notice this has a factor of 2, you're left with s plus r minus p. So you're left with s plus r minus p. So what happens is that the midpoint of AD and BC equals MN. So the midpoint of AD and BC equals MN, since these are both the same. And find the slopes of AD, BC, and MN. Well, the slope of AD, it goes from here to here. Slope of 0 over 2s is just 0. It's a straight line. The slope of BC, it's going to be, if you do 2q minus 2q over 2p minus 2r, it's going to be 0 over this, which is just 0. And if you look at the slope of MN, so MN is q minus q over r plus s minus p, which is 0 over r plus s minus p, which is, so all of the slopes are the same. So we have same slopes, which means we have parallel lines. Same slopes means we have parallel lines. So therefore we have MN is parallel to BC, AD, and it's the midpoint of AD and BC. Now work on the next section about analyzing polygons using coordinates.